it is primarily found in gas-burning stoves, which is used to cook food, and gas-burning furnaces, which is used to heat the house. So now, the basic way a natural gas-burning stove works is that you have the burner, control dial, igniter, and gas tube. The burner is the physical metal part that you place your pots and pans on. The igniter is controlled by the control dial and is going to set off a spark that will ignite the natural gas. The natural gas tube, well, it delivers the natural gas. It is connected under your house to your utilities. The reaction starts as the stove is turned on. When the control dial is switched to light, that causes natural gas to rush into the surrounding air, and this is going to mix with oxygen. However, as the control dial is connected to the igniter, that causes the spark. This leads to combustion. So, more specifically, you're going to have methane and oxygen mixing together. The spark is going to create carbon dioxide, water, and also energy. That energy being the flame that you use to cook your food. And the reaction will continue till the stove is turned off, as the flame from the initial reaction is enough to keep the reaction going as long as there's a steady supply of oxygen and methane. Natural gas burning stoves are very common as they are generally cheaper and efficient. Despite this, there are still some prominent concerns with it, especially regarding safety and environmental impact. Firstly, natural gas burning stoves can be dangerous, as there can be gas leaks, which could release pollutants such as carbon monoxide, formaldehyde, etc., or flammable gases, i.e. methane, which could cause accidental combustion if there is too much in the air. The second is the environmental concerns. As it burns methane and other greenhouse gases, and produces them as well, it is not necessarily the best for the environment. Despite all this, they are still common for a reason. Generally being efficient, and also modern gas-burning stoves have increased safety features to prevent gas leaks and generally limit the amount of gas that is released and not burned off. This is a very common reaction and is probably taking place as we speak. This is because lithium-ion batteries are used to power all sorts of devices, such as smartphones, laptops, speakers, headphones, generally any device that requires a rechargeable battery. So, fundamentally, there are three main parts of a battery, that being the positive terminal, negative terminal, and liquid electrolyte. The positive terminal is also known as the cathode, and the negative terminal is also known as the anode. The actual reaction is what is called a oxidation-reduction reaction. And this is also known as a redox reaction. And this is why it's going to look very different in comparison to the other chemical equation we've seen before. And this is because you can read it in both directions, i.e. left to right or right to left. And this is because there are effectively two reactions going on in one reaction. And this is why it's rechargeable, because you can have two states, one that is charging, and then one that is physically powering a device. So, when it's powering a device, what's going to happen is the lithium ion is going to mix, or is going to react with a metal oxide, usually cobalt, sometimes graphite, sometimes a couple other metals. This is going to cause the lithium metal oxide to flow through the electrolyte from the anode to the cathode. And thus, this causes the electrons to flow from the cathode to the anode. And now, electricity, at this most simplistic description, is just a flow of electrons. Thus, this flow of electrons from the cathode to the anode is what is going to go out and power your devices. Now, eventually, the reaction is going to stop, as there are no more electrons to pass through, and all of the lithium metal oxide ions have gone through the electrolyte and are back at the cathode. Thus, you need to now recharge the battery. This is where the reaction is going to be inversed. The electrons are going to go from the anode to the cathode, and the lithium metal oxide ions are going to go back through the electrolyte from the cathode to the anode. And thus, the cycle will continue on. Now, there are a couple main concerns with this, though, as lithium-ion batteries are extremely common as they're cheap and cost-effective. However, they are, again, fundamentally dangerous, as they are very flammable and combustible, and also degrade with stability and safety over time. This is also why your iPhone loses charge after a couple years of use. Another concern is also that the actual mining of lithium and cobalt and other metal oxides is generally very bad for the environment and has called into questions for possible replacements. Despite all this, though, it is still very common and generally is one of the most important chemical reactions that happens in our modern society.